Okay, let's start. So, hey guys, welcome to the first session of Contain the Code. So this is a series of knowledge sharing sessions for container technology, Docker, and things related to that. Now, today's session is being taken by me. I'm Aditya, and we also have Shantanu here. So yeah, let's also this session. Just before we start, this session is being recorded. So in case your friends miss it, the recording will be put up on a YouTube channel soon, so they can watch it there. And you are totally free to ask questions anytime during the entire session. You can unmute yourself or put the question on chat. And if you're still too shy to ask, we also have a link here. I'll put it here. Yeah. So I put it on the chat too. You can post a question there. You can post it anonymously. It doesn't matter. But yeah, and we can solve, answer it for you. So starting, let's begin. So yeah, as I said earlier, a bit about the series. So this entire KSS series is divided in three parts. Today is the first session, which just gives an introduction to virtualization, virtual machines, and then containers, and interactive session with Docker, a brief demo. Then we also have, then the next session is, we go in depth about containers. We find out how they actually work. So internally, how Docker does its magic, and we try to code a container on from scratch. Then on the third day, it's gonna be about container orchestration. So container orchestration is all about automating creation and management of containers. So if you have heard of Kubernetes, that is one such platform which provides you with, which performs container orchestration. It does much more, but yeah. And that is something which, a lot of, the industry is focusing a lot on right now. So yeah. So starting with today's content, yeah, Shantanu.
Yeah, hi everyone. So I hope I'm audible.
Yeah.
Okay, cool. So yeah, so we'll begin today's session by going over some, I guess, terminology related with containers and stuff, so that anyone who's not familiar with it sort of, is up to date and, it doesn't pose problems later. So beginning with like the basic question, what is virtualization? So it basically is like creating a virtual version of something, and that's the most basic definition you can sort of get for it. So it can be a virtual version of hardware. So when I say hardware, I might mean CPU, your memory, your disk, or it can be your network interfaces, etc. It can be virtual version of something in the OS side. So you can create I would say virtual processors or something like that. So to begin with, we'll just take a definition as running applications on virtual instance of hardware, because that sort of makes sense, I guess, to begin with. And as an example, you can take an example of running an Ubuntu OS in a virtual box on Windows. So VirtualBox is a VM, and I'm pretty sure at least people in CS and IT would be familiar with what a VM is. Yeah. So moving on. Why do you need virtualization? As I already said, if you want to run a program that is developed on Linux and runs on Linux on Windows, one way to do it is you would want to have a VM on Windows, install Ubuntu on it or some Linux OS on it, and then run your program. So that is one use case of of virtualization. Another, more bigger use case, I would say, would be two things. So one is you would want to divide your application. So the application, so when I say application in this scenario, it would be, I would say, a web application where it's running on some server and you're accessing it through your web client. So this application, you'd want to divide this large application into smaller parts, and you would want to do that for several reasons. Off the top of my head, let's say you want to, if they divide into several parts, then you can scale your application better because each part can be scaled differently or increased or reduced differently based on demand. Uh, and yeah, so I won't go into the details of this, I would say, because we'll be covering this in session 3. But yeah, that's one of the reasons. And one more important reason is you would want to isolate processes running on each virtual instance. So you would want a setup where different processes, you have two different processes, and you don't want each process to affect one another. Or rather, let's say you have two different applications running, and you don't want, let's say the applications are application A and application B, or in short, app A and app B. And you don't want app A to influence app B or app B to influence app A. So you would do that by having app A and app B in their own virtual instance, so that they don't have any scope for interacting with each other, and hence they're isolated. So there, I would say that one of the two main important reasons of virtualization. Yeah. So moving on, uh, we'll look at some of the ways in which you can achieve this, achieve virtualization. So we know, I mean, I'm pretty sure everyone would have heard of a VM and used a VM as well. So VM is short for virtual machine. And to put it in one sentence, a VM is, what it does is it emulates a computer system on top of a computer system. So it's sort of like, you have a host machine and you have a VM software, and the VM software has its own virtual hardware, and then you run an OS on top of that. So yeah, just a second. Okay, yeah, sorry. Yeah. So for applications that run on top of the VM, it looks as if they're running on top of a normal OS, right? And I mean, the applications can't really make out a difference between if it's running on a virtual machine or on the host OS. So they don't really see the difference. And the applications that run on different VMs are isolated, obviously. So that's the point of virtualization also. And as you can see in the image, you can see a couple of, so the image is quite small, but you can see a couple of virtual machines that are on top of one blue box. So that's known as a hypervisor. So to put it in brief, hypervisor is sort of like a manager of VMs. So with the help of a hypervisor, it's some sort of an application with which you can create VMs, manage VMs, delete VMs, stuff like that. So I won't go into detail because it's not really important to understand how it works. We are just rather going over the terminology. So some of the common VMs that that we come across are VMware and VirtualBox. So moving to the next way to virtualize, it is the hot topic, containers. So you would say, one could say that container is a lightweight VM because it's sort of, when you use containers, it feels like a VM, and it does everything that a VM can do, and it is much more lightweight than a VM. So that's why you would get a perception that it works like a lightweight VM. So that would be a good description if you had to put in 2 words. But yeah, so in reality, containers are, I would say, much different than what a VM is, and we'll look at that in a little more detail later. But as a VM, you can use a container also to isolate applications. You can spawn up different containers, and applications running in different containers can't isolate each other. I mean, can't interact with each other, can't affect each other's operation. So a big example for containers, for managing containers, creating containers, is Docker. So Docker is a popular tool that's often used. And in many ways, it's sort of synonymous when you think of containers, Docker always comes to your mind, something like that. So if you go to the next slide, I have sort of put the images in the previous 2 slides in a one slide so you can see it clearly. So on the left, you see the instance of VMs on a host machine, and on the right, you see a couple of containers on a host machine. So the big blue border around it basically represents the host machine, and the internals are VMs and containers. So on the left, you see that the VMs are running on top of a hypervisor, and in each of the VMs, there is a guest operating system and an application running. On the right, you see the Docker application running on top of the host OS, and there are a couple of apps running in each of the container. And in each of the containers, you don't see that guest operating system written. So on the left, you see that. On the right, you don't see that. So what that means is, in a VM, each of the VM has its own operating system running. So, and the application has to run on top of it. But on a container, you don't see that. On a container, the operating system of the host OS is shared between all the containers. So if you see the image carefully, on the right, you see host operating system. On top of it, you see Docker, and then you see a couple of apps. So all the apps are using the OS they're running on is the host operating system. So what it means is each of the containers are sharing resources of the origin of the host OS, and what that implies is each of the containers are lightweight, and that's why you would see the boxes of each of the container are much smaller than the boxes of the VMs. The VMs are big. The VMs are big because they have their own OS, and OS are typically pretty large in size. And that would be like one of the main reasons that VMs are much bigger than containers. And because of that, you can see that you can stack a lot more containers in a system than a VM. So on the left, you see only 3 VMs. On the right, you see 6 containers. So on the same host OS, you get a lot more containers. So you sort of summarize all the points I've said. If you can go to the next slide. Yeah. So I've just summarized all the points I've said so far in one, differences thing. So on the left hand, I'm just describing the containers, and on the right, I am counterpointing it with the VMs. So firstly, VMs are completely isolated and are like independent machines. So when you have 2 VMs in your system, they're actually like 2 different machines that are running on your that's running, and there is really no way in which you can make them apps in between in these 2 VMs to interact. But in case of a container, the containers are, I would say, less isolated and are not like independent machines. So it may not exactly make sense when I say it like that, but I would say that when you have applications running in 2 containers, by default, you cannot have interaction between the 2 apps that run in containers. But if you want to, there are ways in which you can make an app in one container influence an app in another container. By default, it's not possible, but there are ways you can do that. And that's why I would say it's less isolated, and a VM would be more isolated. And again, as I already mentioned, each VM has its own OS, and which would imply that each VM can be running on different operating systems. But on the container side, we see that containers share the OS of the host. And in here, I've taken an example of a Linux OS. So if the host OS is Linux, then all the containers will be running on Linux OS, which would mean that 2 containers running on the same host cannot have different operating systems. So if you're running on a Linux OS, you can't have a container that is of Windows OS or something like that. So that's not possible. So thirdly, yeah. So I've written the point like containers virtualize the OS and VMs virtualize the hardware. So what that means is, in a VM, we would virtualize hardware in the sense that we would virtualize, so by hardware, I would mean, CPU, memory, disk, and all that. And that is what you would virtualize. So what that means is each of the VM has its own virtual copy of these hardware devices or something like that. And that maps to the real hardware. So as I already mentioned, virtualizing something means you have a virtual version of something. So each VM has a virtual copy of its own hardware, and that maps to the real hardware. Right. So I hope that sort of makes sense. And virtualize the OS on a container side means that, so in the container side, so we would virtualize some of the OS aspects. So what I mean is when you talk about OS, some things that come to mind are, file systems, processes, host name of a computer. So these are all resources that are available at the OS level. And these are resources that you're virtualizing. in a container. So each container has its own copy of these virtual things. So like the process space is different for each of the container. The file system may be different for each of the container, something like that. So since we are at the OS level, that's why I would say it's virtualizing the OS, right? And as I already mentioned, since the containers are running, containers share the OS, they take up less space, and typically container sizes are in MBs. And since VMs have to run full-fledged OSs, they take up a lot more space, and the size is typically in GBs. And also, what this means is that VMs will take typically will take more time to start up because they'll have to boot the OS and all that. And containers are typically take less time to start up. I mean, I don't think you would actually even notice the startup thing if it's a lightweight, very lightweight container. Okay, so moving on. So
before we can move on, we have a question.
okay.
So yeah.
If a team is using
Sorry.
Docker to develop the project, it's So can you say that if a team is using Docker to develop the project, it's a way to replicate one machine into every team member's machines, so it removes. Yes, yes. So we can say that. Okay, so I'm sort of coming to that. So since we're going to the Docker slide, I'll just explain this. I'll answer this question while I'm explaining this slide, so that I think will sort of make sense. Yeah. So moving to the next slide. So far what we saw was we just saw some terminology. What does virtualization mean? What a VM is? What a container is? How are they different? So now we'll get a bit more concrete and see a popular tool, that is Docker. So Docker is used for creating, maintaining, and distributing containers. And as I already mentioned, it's sort of like synonymous to containers now. Like you think Docker if you think containers. And so if you can see that last line that I've written, a Docker container image is a lightweight standalone executable package of software that includes everything needed to run an application: code, runtime, system, tools, system libraries, and settings. So this sort of answers the question that came up. So what this means is, so let's say I'm developing some sort of application in my system. So when I develop applications, I won't write code for everything, right? So I'll write code for my part of logic, and I might have some dependencies that is maybe some shared libraries or some library that has some function that's useful for me. So I'll download those libraries in my system and import them in my code and work with it. Now the issue is if I just share with someone else my code, it's not going to run on their system, right? Because they don't have the dependencies that I have. So one possible solution is you can use Docker containers. So what you can do is I can package my application along with all its dependencies and runtime. So by runtime, I would say if I have a Python application, then I'd have Python in it. If it's a Go application, I would have Go in it. So along with the runtime and all necessary libraries, system tools, and settings, I'd package that in one container image and send that to someone else. Now, if they have Docker installed, they can easily just run my application on their system, even though they don't have all the dependencies, because the container image has instructions to obtain those dependencies. So yeah, so I hope that sort of made sense. Sort of simplified Docker. So it's a package software into standard units of development and deployment. Yeah, so it's as the question said, it's also, it works on my system problem. I can do something on my system, I can share it with others, and they'll also be able to run it quite successfully on their system as well without any problems. Okay, so we can go to the next slide, I guess. So yeah, do interrupt me if you guys feel like I'm going too fast or you're not understanding or anything like that. You can feel free to unmute and ask as well. Okay, so yeah, so from now on we'll go into the demo part of the session. So we'll be going into our terminals and showing you Docker commands, actual Docker commands, to get comfortable with it. So yeah, so for installation of Docker, so there are two ways you can follow along with this. You can either install. So if you already have Docker installed, so well and good, you can use it or you can quickly go over this link. So Aditya, you might want to put these links on the chat so they can access it. So yeah, you can. Yeah.
I think you should be able to put it, right? If you have.
Oh, okay.
I don't. Let me. I think
Yeah.
I missed to add it on the slide. So yeah.
Yeah, sure. I'll add it. Just a second. So you can follow the instructions in the first link, wherein you can actually install Docker on the system. But I would say the faster and easier way, if you don't have Docker installed, is to use the second approach, where you can access I would say Docker playground uh, on your web client, and with which you can easily run your Docker commands and follow along.
You can also put that get Docker link if you have that.
All right. Uh, so there is also one more way to follow along. Just a second. So you can try out this link as well if you want to install Docker on your system. So I put it get.docker.com. So if you open that link, on the top you will see a set of commands to run. So you can sort of download this file and run the shell script. And what should happen is it should work on the fly, in the sense that it should work without anything else. But yeah, we also have not tried it, so we're not completely sure if it'll work out. But yeah, theoretically it should just work by running that one command. Yeah, so I guess we can wait for maybe 1 minute.
Yeah.
Yeah,
Guys,
like
if you have Docker installed already, or you're using the labs, or you have installed Docker now, just raise your hand so we know when to continue.
yeah.
And it will be good if all of you are doing this activity with us, so it'll be easier for you to remember and understand. Okay, we have one more question till then. Do I lose my data when the container exits?
Yeah. So if you start a container and if you do some work in it, create some files and stuff like that, once the container exits, you lose your files. So if you do want your files to persist, then you will have to look into something known as volume mounts in Docker. Yeah.
Okay. So someone asked, what should be the laptop specification to run Docker, as my laptop is trying to slow. It's not really, I'm not really sure about the exact specification, but it's not something very high. For installing Docker, at least for installing Docker alone, you don't need high-end specs. You just need storage. For running the containers, you might need it. The amount of containers you can run, what images you can run, that will depend on your laptop specs. So just installing shouldn't be an issue. And containers, there are a lot. Usually the containers are very lightweight, so you should be able to run at least 2-3 containers without any issue, even if your laptop is slow. And if you want to try out the commands right now, and you don't have Docker installed, I would say go to the second link, the lab playground, and it'll be easier to experiment with Docker there without messing up your system.
Yeah, I think you just need your GitHub account for it. So that's very simple to set up.
Okay, the next question is, how can we use Docker in our project? We'll come to how to use we'll be covering that in this session itself in the later part. What is Kubernetes? Kubernetes is a tool for managing and orchestrating containers. You can learn more about it in the third session. which will give an intro to Kubernetes and will go in depth too. So yeah. Okay, guys, can you raise your hand if you are, if you have Docker available now, like already installed? And all right, so I see a couple of, okay, I see a lot of raised hands. Yeah, okay, this number seems good. I think we have about
12, 13, yeah, 15, I think now.
Yeah, 15, yeah, about 15. So yeah, I think that should be good enough. It'll be really helpful, for you if you like follow us and try the commands on your own.
Yeah,
Yeah,
by
this
the
looks
way,
good. I think we
Aditya,
can continue.
in the Kubernetes lab thing, can they open 2 terminals? Like, I'm just not sure.
I think they can. I'm not sure. I've not tried that. You can open multiple containers. I'm not sure about
Multiple containers are possible. 2, yeah, it's not that big an issue, I think. Yeah, fine.
Okay, I think we can start the demo then.
Yeah, shall I present now?
Yeah, I'll start it.
Okay, I'll start the presentation.
We have one question. Can we use the same command on the online playground? Yes, definitely. So that's the thing about Docker, right? It's universal. So if you're running Docker on that system and you're running Docker on your system, there's not going to be a difference. So you can use the same commands.
So let me know when you guys can see my screen. So you can see my screen, right? All of you?
Guys, I can see it. I'm not sure about others. Can someone raise their hand and let us know?
Yeah, it's visible.
Yeah, the switching between slides is okay, right? I mean, also this, sorry. Also the font of the terminal is also fine because dark text, I'm not sure.
I think you can increase it by 1 or 2 points, but yeah.
Now?
Okay, a bit should more. Be, yeah, fine.
Okay. Okay, so, yeah.
Okay, can you zoom in more actually? Someone just said zoom in.
Even more, huh? Okay.
Yeah.
Now? Yeah, you guys can, someone can unmute and let me know also. Yeah.
Yeah, that'll be better. I think this should be enough.
Fine, it's fine.
Yeah.
This is fine?
Yeah.
Okay, fine. Yeah, it's pretty big for me. Yeah, fine. Okay. Okay, so I'll get started. So we'll go over some common Docker commands that's, so we often use. So we'll move on to, so ultimately we'll show you how to run an application as someone asked. But before we do that, we just want to go over some of the basic commands so that everyone is comfortable with the these commands, and then we can move on to the actual application. So the first command that's written here is listing containers. So you can do Docker PS, and you can see all the containers that are currently running. And since I've not really started any container, it'll be empty for me, and it should also be empty for you because you don't have any containers running. So we'll keep coming at this Docker PS command again and again because in the demo I'll be creating containers and all that. So when I create and stop and all that, I will see the Docker PS command. So next we have the Docker pull. Okay, so before I go into that, so I'll keep switching between these two slides. One is common commands, another is Docker architecture. So it's a pretty big slide, but I want you to focus on this part and this part. So we see something called images here, and we see a registry here. So firstly, we'll define what an image is. So we know what containers are. So, but what is an image? So in Docker, an image is a it's a set of instructions for building a container. So it's a set of instructions for creating containers. That would be a better definition. Okay. So it's like a read-only template with which you can create multiple containers. So for example, this is a symbol of Ubuntu. So that signifies an Ubuntu image. And using the Ubuntu image, you can spawn several containers. So each container are different, but they are created by the same image. Okay. So I hope that clarifies what an image is. And we see something called a registry. So when you install Docker, you don't have any images in your system, right? So you can do this command docker space images to see a list of images in your system. So on my system, I have some images because I've already sort of downloaded some of them. So I'll see some of them, but in your system, you might not see anything. So you can see the images in your system. But if you want to download some images from online, so the standard place is so the place we are downloaded from is called as a registry, and the standard place from where Docker images are downloaded from is known as Docker Hub. So the Ubuntu image is present in Docker Hub, and you can download it into your system. And the command to do that is Docker pull. So if it's so it's sort of similar to Git commands, I would say. I mean, in Git you would use clone, I guess, but yeah, there is some similarity. So Docker pull, so Docker space pull space Ubuntu. So when I do this, uh, it will download the Ubuntu image from the Docker Hub registry to my system. So currently, you see that no download happened because I had already downloaded the Ubuntu image. For the sake of the demo, I didn't want to download it during the demo. But it's like around 70 MB. So if you're using the playground, then I think it should be done in about 15-20 seconds. Uh, yeah. So after run the docker pull command, you can do docker images, and you should be able to see the Ubuntu image in the list of images. So the repository name should be Ubuntu. The tag should be latest, and the size, I think, yeah, it should come about same for you as well, around 73 MB.
One thing that I would like to point out here is people who are actually trying the commands right now, and the image gets downloaded. Just notice how it's being downloaded. You see multiple hashes showing up, and those hashes will be, downloaded and stored in your environment individually. So that is something that we will, get into later in a part of the session. Like what
I
that
can
actually
try
means.
it out, I guess. Is there a small image? I'll try Alpine.
Yeah,
I can show it.
yeah.
Only if I don't have Alpine already. Okay, I have Alpine. Yeah. So
Just give a tag. Just give a tag. Alpine 3.1.
okay, some version.
Yeah.
I will just do Ubuntu. So I'll just download a specific version of Ubuntu image. So let's see if that shows up for me. Yeah. Okay, so this is what Aditya was mentioning. Yeah, so
Yeah. And just to make it clear what a registry is, it's like a standard place to publish your Docker images. Just like you have GitHub to publish and share your code, a registry exists to publish and share your images.
okay. So I hope everyone has downloaded it. I guess you can use the show of hands thing again if everyone is following along or not.
Yeah. If you guys are having any issues with these commands, feel free to put them up on the questions or chat or on that slide question link. Or you can unmute yourself also. Right? Just ask it directly. Okay. So I guess we can continue.
Okay, fine. Um, yeah. So the next command written here is Docker images. So, but I've already sort of shown it. So Docker images, you can see all the images in your system currently. Yeah. So now that you've installed you downloaded the image. The next thing you would want to do is you would want to create a container out of it. So as I already mentioned, image is a set of instructions to create a container. So an image is not a container. With the image, you can create a container. So to create a container, the command is docker run the image name, right? You just write this and it should create the container. So I can do docker run ubuntu, enter, and the container runs. So when I did this, nothing really happened, right? So what's happening? So we can use the old command called docker ps to see if there are any containers running, and they see the container is not running. So what exactly is happening? So there's also another command known as docker ps minus a, which shows you something more. So if you look at this closely, you will see one container is there, and if you look at the status, it says it exited 24 seconds ago. So what happened was, when I ran Docker and Ubuntu, in Docker run, I have to usually specify the command I want to run. So the command I want to run is usually specified after Ubuntu. Since I didn't specify any command, it started the container and stopped the container. Like it didn't do anything else, which is why you can see that you can see the container here in ps minus a showing that it has exited. Now to do something, useful out of this, to really show you that a container is sort of working out. Yeah, so let me do this. Okay. So you can do docker run ubuntu, and we'll run a simple sort of program unit. So we run sleep 10. So this program does pretty much nothing. It just sleeps for 10 seconds and then quits. So I can do sleep 10. I'll enter. And now if I type in docker ps, you can see that the container is currently running. So there's a container and the status is up. If I run, so meanwhile, the previous Docker run 10 seconds were over, so the program quit. So if I run docker ps again, you don't see it, right? Because the container exited. So I can do docker ps minus a to show that both of them are present. Okay, so far I haven't really shown you how to use containers usefully. I'm just sort of demonstrating commands. So maybe 2 more commands in, and I'll actually show you some interesting stuff like going into a terminal, into a container using a terminal and all that. So just bear with me. So yeah, so we just have one more command, that's docker exec. Yeah, so or maybe I'll skip that. I'll come to docker exec later, and I'll show you how to run a terminal inside a container. So that will be a bit more interesting. So I'm not sure if people using the playground will be able to do this, but yeah, it's sort of more of a. So you will definitely be able to do this. So I'll write a command here. So the command is docker run. There are a couple of flags that we didn't see before. There is Ubuntu, and the command I'm running is bash, bin bash. So these flags are not so important. So minus minus rm says that this container should exit after it's finished running, and minus it is basically telling that the program I'm running is bin bash, right? And bin bash is an interactive program. I would want to give input to it, and I would want to see the output produced by it. So minus it ensures that the interactivity is works out fine. And if I click enter now, so after I run this command, I see that I'm inside a new shell. And if I do ls init, there are a couple of files in this shell, right? So maybe I'll go inside home and it's empty. Now if I go inside the home directory of my host OS and see the contents, you can see there is one folder, that's my user folder. And in the container, I can create a file, let's say container user. So when I do ls, there's a user there. But when I do ls in host OS, I don't see that. So if you look into this, the container is having its own file system that's different from the host. And what we do inside the container is not affecting the host. What we do inside the host doesn't affect the container. So that's where we have sort of achieved virtualization, I would say, or even isolation, because you don't really see what's happening inside the container in the host, or at least it seems like that. Now, yeah. So now I wanted to show one more thing. So let me start another container. So yeah, so this part is something I think you guys will not be able to do. So anyways, so in the top one, I have a container already running. Now in the bottom part, I will run another container. So these are basically two different terminals. So docker run --rm, the same command, --rm -it ubuntu bin bash. I can run this. And you can see that it opens a new terminal. And you can know that both the containers are different because if you see the number here, so that's the host name of the container and the host names are different, which sort of indicates that the containers are different. Now to show that each of the containers has no effect to each other, so let me run a command here, sleep 20, click enter. And now if I do ps aux, so with ps aux, what I can see is I can see all the processes running inside my container. And if I click enter, I can't see the sleep process because the sleep process is running in the first container. And the second container is isolated from the first container. Hence, I cannot see processes that are running in the other container. Now, the interesting thing is, okay, so I'll delete the second container, or I'll exit from the second container. So right now, my top terminal is a container, and my bottom terminal is my host. So the interesting thing is, I'll run the sleep command again. So maybe for 30 seconds. And I'll try to find this sleep command in my host. So let's do ps aux. Now, since there are a lot of processes in my host, I don't want to see all of it. I just want to see if there is a sleep command that I can see in the host. I'll click enter. And you can see this line here. The process running is sleep 30. And this sleep 30 is in fact the sleep that's running inside the container. So what that means is processes that are running inside the container are not visible to any other containers, but they are visible to the host. So that's what I sort of mean when I say that the OS is virtualized or the OS is shared between all containers. The OS can see everything that's happening in each of the containers. So I hope that sort of clarifies some of the explanation I gave about virtualizing the OS, right? So we'll look more into all this in tomorrow in the next session, where we see how to build a container from scratch. But I hope this sort of gives an inkling of some small things that's happening. So basically, this sort of stuff wouldn't have worked in a VM, right? In a VM, I could, if I ran sleep command inside a VM, in the host OS, I can't do ps aux grep sleep and see that command. It just only will work out in the container. Okay, so I hope that's fine. Yeah, so the only one Docker command is kept was docker exec. So I'll just show you guys that. So I can do docker ps right now. And you can see currently there is only one container running. And that makes sense. The one container running is this one. So if you look at the ID, it looks the same. And by the way, one thing I forgot was each of the container has its own container ID, and it also has a name. So a name is a name given by Docker, so that the name and container ID are sort of equivalent. They can be used interchangeably in commands. And we have a name because container ID is sort of cryptic and hard to remember. So we have a name to sort of easily use it in commands. So if I now want to have a second terminal inside the same container, the way to do that is Docker exec. I'll use this. And I would say bin bash. It should probably work. Okay, that doesn't work. Okay, so I would rather show you how to run a command. So
I think if you give the flag again, -i or -d, it will work.
oh, okay.
It has to be interactive.
Oh yeah, nice.
Yeah.
So yeah, so the flag that we use for run, we have to use it again here. So right now we have two terminals inside the container, and right now, so these two terminals are in the same container. So right now, if I actually do sleep 15, and if I do ps in the second terminal, I'll be able to see the sleep command because these both terminals are in the same container, right? So that's why I can see process running in one terminal in the other terminal. So if I do ps, sorry, not ps, if I do docker ps now, I can see the container is running currently. Now, as soon as I exit from the terminal that's running in the container, that would mean all processes running in the container have terminated. That would imply the docker ps would show nothing. So I'll exit from the container. I would run docker ps, and the container and the list is empty. Of course, if I do docker ps -a, there are a lot of containers that you see. I think 2 of them, and they're all exited, right? And the way to remove them, like permanently from even docker ps -a, would be docker rm, and you would want to view these names. So the names that are present in the list of in the docker ps -a, you provide them. You click enter, and they'll be deleted. So now you can do docker ps -a, and you will not see them in the command. Another way to do it is if you have a lot of stopped containers and you want to remove all of them at once, you can do, I believe, docker container prune. It will remove all the containers that are stopped. So you can do this. Even that is an equivalent way to remove all the stopped containers. Okay, so I hope this sort of, so that's the end of the demo from my side. So there are a lot more. So there's one more command for seeing logs. So that will be shown by Aditya. And there are a lot more commands you can do there in Docker. So we have just scratched the surface. Like there are a huge amount of commands. So you can sort of check it out when you're later on. So I hope this was fine for everyone. If you guys have any doubts with any of the commands, if you had any difficulty running them, you can let us know. So
yeah, I think we'll take a break for a minute here and let them try out the commands. And if you have any doubts, just let us know.
Yeah. So I guess people who could successfully do it could raise their hands or something, maybe, to let us know.
Yeah, can people who were able to follow this up raise their hands? So we'll know if we are actually explaining well.
Yeah. Okay, so quite a few people are there, I think. 10 people.
Yeah. People who couldn't follow, and if you have any doubts, feel free to ask.
Yeah, any command that I've shown or anything else.
Again, you can put it up on the chat, ask it directly, or you can post the question here. I put the link on the chat. Okay, there are a couple of questions. How can we do CI/CD using Docker? That is, yeah. So I'm hoping that you understand what CI/CD is. So CI/CD is it stands for people who don't know continuous integration and continuous deployment. So this is like something that is used a lot in development right now, and what it basically means is that when I am when we are writing code and and we are creating some software, and we're doing it in teams. So the CI part makes sure that the code follows certain standards and integrates with the existing code, and make sure it is acceptable with all the teammates, while the CD makes sure that the actual deployed version of your code. So your code will be deployed somewhere. Say if it's an app, it will be deployed on Play Store as an app listing, or it's probably a server which is running on some cloud. So the CD part makes sure that whatever new code you write gets deployed automatically. So Docker is used a lot here because the platforms, the systems which do this thing, so automatic deployment or automatic checking. So integration, normally they perform tests and stuff. So those things are usually done in containers. And yeah, you can say those containers are usually Docker. It doesn't have to be Docker containers, but yeah, you can use Docker containers there, because as a system, as someone who's providing you this service does not want I like say I'm providing you the service of CI/CD. I would not want your code to run freely in my machine, right? I would want it to isolate from my system. So that is where I use containers. You could also use VMs, but then again, it's very difficult to create a new VM. So we saw that it only took seconds for us to create a new container, while creating a VM takes a lot of time, and it takes a lot of resources also. So that is where containers are useful. I hope that answered your question. You can put a thumbs up on the question if the answer is satisfactory. The next, what is the difference between exec and run?
Yeah, the run.
So
Yeah, you can.
yeah, go on.
So
Okay.
I believe Docker run, when you run, when you provide the command, so when you start the container, it's running that command by default. It's going into that process directly. Docker exec you would do. So let's say you did Docker run, and let's say you have some web app, so you're running some server. So Docker run, and you start some web server, right? And then if you want to go into your container and check some status about the container, you do Docker exec and say space ls. So if you do Docker exec ls, you can just see a list of all the files that are in the container and stuff like that. So Docker run is to start a container with the application. Docker exec is, I would say, you would mostly use it for debugging purposes. Maybe that's one good use case, I would say. If something is not working as expected, then you can you can spawn a terminal after the container has already started, and then see if anything is going wrong there. So I hope
one
that
main difference, I'll just add on. One main difference is you can't use exec to create a new container. If you want to create a new container, you have to do Docker run. Docker run always creates a new container. And Docker exec always works on existing containers. That's the main difference. So like you can't use them interchangeably. You can use, say you have an existing container and you want to spawn a new process in that, then you would use Docker exec. But if you want to start a new container itself, you would use Docker run. Yeah, let me just present these questions actually. Shantanu, can I start? Can I present?
Yeah. I'll stop.
Yeah. Let me know once my screen is visible.
Yeah.
Okay. How to? Yeah. Okay. Uh, just so we have one more question here. So there are a lot of websites that provide us with a virtual thing. Yeah, they are. So there's this interesting project called Docker and Docker, where people are trying to run Docker containers inside another Docker container. Usually by default, it is something which is not really you can't do it directly. Like you can't just spawn up a new container, install Docker there, and make it work. There are some other complications and certain things that you need to find configure. But yeah, if you so this lab that we shared, labs.playwithcase.com. This, if you would have clicked the button called add instance or something, it actually starts a new container, and inside that container you're using Docker and creating new containers. So yeah, I hope that answers your question. All right, I think we can continue to the next part. So right now we saw till now we saw how to use existing images, create a new container, and but I think a more interesting part for most of you is here is like how would you pack your own code into an image and share it with others and run it in a Docker container. So yeah, we'll be learning that here. So this is again going to be hands-on. So I would say first we'll take a sample app which is available at this repository. I hope the text is visible. I'll put the link also here on the chat. Yeah. So you can clone this repository and we can just start. And while you clone it, you can just go over the how we defined an image earlier. So Docker container image is a lightweight standalone executable package of software that includes everything needs to run an application, code, runtime, blah blah. So so in simple terms, it just says that everything that you need to run your software, all the libraries, the runtime variables, and all those things, and any required files can all be packaged into a Docker image and shipped anywhere. And then you can use a container to create a running instance of that image, right? So I'm not sure if I would give the right analogy here, but say when you're installing an operating system in your VM, you use a .iso file, right, which contains when you're installing an operating system, you use a .iso file which contains the entire operating system packed in it, which has the entire OS packed in it. So you can think it's kind of similar to that, but yeah, don't think it's exactly the same. Yeah. So if you guys have successfully cloned the repository, let me know. We can start there. You can raise your hands again.
Yeah, I hope everyone is familiar with Git, right? Maybe I can just write the Git command. Oh, you can download it, right? That's also fine. Yeah, if you're not familiar with Git, there's an option to even download it as a zip file. So
Yeah, if you're running it in the lab, you can. I'm sure there'll be Git available in it, and you can just do Git clone. If it's
correct.
not, just do sudo apt install Git. It'll work. Actually, Shantanu, can you try that once in the lab? And
Yeah, let me. Yeah, I have to just spawn it again. Just a second. Yeah, Git is there.
Yeah. So yeah, you can just do git clone, and you can get the exact command from the repository page also if you press the download code option. Yeah. So just
Yes.
raise your hands when you have the repository. We wait for another, I guess, 30 seconds or something. So yeah, the reason we doing this and making you do it is because it's easier to understand and remember stuff like this. Yeah. And this is quite useful from what I've seen. Containers are being used everywhere now. So yeah, almost any major project you go to, you'll see that there is a Docker file present there, which means that this thing supports this software can be run in a Docker container. So okay, I see quite a lot of raised hands, so I guess we can continue. Yeah. How to build a Docker image? So Docker does the task of building the image for you. It has it has commands for building the image, but you need to tell it how to package your code into the image. So that is where a Docker file comes in. A Docker file is a set of contains a set of instructions for the Docker daemon. If we go back to the architecture slide, so this is the Docker daemon, right? And this is the Docker build command. Let me just point it. Yeah, Docker build command. So the Docker daemon, reads your Docker file, and it tries to follow those instructions and package everything into an image. So let's start with our sample app. I'll have to come out of this. Yeah, is this visible? Do I need to zoom in more? Oh, this is fine.
Yeah, this looks okay to me. Someone else could confirm.
Yeah, can others also confirm once? You can raise your hand also if it's fine, or put a yes on the chat.
It's fine. It's fine.
Okay. Yeah. So let's go to repository. Okay. So I have some changes already here. Let's do those. Yeah. So I have the same repository. Why are there things there? Yeah. Okay. So, and if you have the repository and you go into the folder, there'll be a folder called session1, which contains a simple, Go app. I can just show the app here. Yeah. So this is a very simple app. It just runs a server on port 8080, and okay. Yeah. Instead of showing the code, I think I should actually show you how it works. So if I just build this, yeah. and I run the server. So this started the server and it's listening on port 8088. Yeah. And now if I just curl that port, oh yeah. Yeah. So yeah, I got a 404. I think it's true. Yeah. So yeah, it's a very simple server which just returns me a reply to a ping when I go to this URL. Any other URL, it just returns a 404. Yeah. Now, right now I am running this on my host, right? But now you want to package this and create a Docker image, right? Uh, huh. So a few things that what do you think should go into the image for running this binary? You know, so the first thing we would do is we would need is the Go runtime, right? Uh, so because this is a Go application, all the libraries that it uses for running the app, for running the binary, all those things would be needed. And also we will need the command Go to build the binary when we're telling Docker to pack it into an image, we will have to tell Docker how to build the image out of the code. I mean, the build the binary using the code. So that is something we'll need to tell, and for that we need Go, right? So the image needs to have that also there, and the standard C libraries and those things, which most of the which okay, you might not know this, but Go actually uses those internally. So those things will be needed. Uh, yeah. Now the first step to create your image is create a Docker file. So I'll add a new file here. Yeah. Can I zoom? Yeah. Yeah. I hope this is visible. Okay. Now, usually what you do is the first step in most of the Docker files you'll see is from, then some image name. So let's say Golang, then. So you don't need to remember these image names. You can just search for them. I just remember this because I created this image a while back. Yeah. So what this tells Docker is the Docker daemon is that whatever I'll be building, I'll be continuing on top of an existing image, which is called Golang, and a tag. So if you remember when Shantanu was pulling the Ubuntu image, he mentioned the name of the image. That was Ubuntu. So a similar image is available, which is called Golang. The tag is the complete name of the image is the image name and a tag. Usually the tag is used to version the image. Okay. So in Ubuntu itself, you can have different versions, right? You have currently it's 20, but there was 18, 16. So this tag can be used to differentiate between those versions. So this version of Golang image is Alpine called Alpine 3.13. Yeah. So this is that. Now, why am I using Golang image? Because it already, comes with the Go, the required binaries for building by Go code. You could also use that Ubuntu. So you could use Ubuntu here and then install Go manually using the instructions which are given to install Go on their website. And then, use that. But, why make our life harder when this thing already exists, right? So if we use this, so yeah, also I've seen a lot of people who know about Docker files think that this has to be always the first step, but it's not. And and you should be able to figure it out simply because think about the image, the person who created Golang, this image. what did they use? They probably used, okay, this is Alpine, so they would have used the Alpine distribution. Alpine is a Linux distribution, by the way, just like Ubuntu. It's very lightweight. So yeah, that is why people use Alpine, because it's light. So anyways, they would have used the Alpine base image. But what about the person who created the Alpine base image? What did they use? They wouldn't have anything, as a base image, right? So yeah, you don't really need this first command. You can directly start doing things in your image without this. But this is usually in normal use case, you need all this because it provides you prepackaged stuff. For Ubuntu, it gives you all those root folders and all the folders required there, all the required binaries and stuff. So yeah, moving on. Now, once we have our from command, the next thing we need to do is send our code. So how the image building process works is the Docker daemon takes every command, okay, executes that command, and it creates kind of like a container out of it, okay, and then it takes that container, data from that container, executes the next command, so and creates a new container out of it, right? Or you can say an image. So it's an incremental process, and that's where the layers come in. So if you remember when you were pulling the image, there were different layers. Those layers are basically different different stages in the building of your Docker image. We'll see that here also once we start building the image. So now if I just take this statement and build my image, right? Let me just do it. Yeah. So for building an image, the command is docker build, then -t to specify the name of your image, which is the image tag. So let me just name this. Yeah. So this is v1, right? And then we can just we need to tell what is the current context we need to build it from. So a Docker context is basically when you are building the image, you need to tell from where you'll be, getting your files for code and stuff from your host. And so you need to tell the path for that. And that is what we call the Docker context. So right now, when I'm building this code, I'll need only files from this directory. So I just give this path, the current directory, which is a Docker. And we start building. So it sends the Docker context, which is 10.75 KB. And this is like everything, all the files here, right? That is the total size of this. And the step one was from that's it. Okay, I think I gave the wrong name. My bad. Docker Golang. I'll have to search it. Just give me a second. Acha. 1.16.0. So yeah. So this is the image name. Now if I do that. So it sent the Docker, it sent the build context, which is this current folder. And it did the first step, which is from Golang. And it created a layer out of it. And the hash of that layer is FE5C. And because there were no further steps, it declared that is the final image. So successfully built that. And it tagged that image with a name, right? So internally, Docker identifies all of its resources with hashes, okay? But for making it easier for humans to understand, they are tagged with names. So a container has a name, an image also has a name, but it's actually identified by a hash, right? But this is not enough for us. This is just, right now the image that we have is just a Golang image with not, and we don't have our app in it, right? So the next thing is we need to, build an image which has our code. So what we do is there's an instruction in the Dockerfile which says copy. So what this does is it copies, some stuff from the source to the destination, and this source needs to be in your Docker context, right? So I sent my entire current folder into the context, so I can do this and do this, right? So what this does is it copies my entire context, the current context, into the working directory of the container which is being used to build the image, right? So it, as I told, it builds a container and incrementally adds these steps to it, right? So this would mean that it copies everything to the root directory of the container. So if we run this, so it executed that. Now notice this, okay? So successfully built the last one, and it tagged that as the our image. But this layer was still built, and if you notice, the hash is exactly the same. That is because this instruction is still the same, right? It's not changed. So the result of the instruction also supposed to be the same, is going to be the same. So it's the same hash. Yeah, and then we have this. So let's see what is there in our image right now. Okay, so Docker run, what's the name of this? Wongo v1 ls. Let's see what is there in this. Yeah, so you'll notice that it's our code, right? So the code is actually stored in a container right now. It's packaged in the image, and when it is unpacked and you start a container out of it, it'll be available in the file system of the container, right? So we have done this, but let's just remove the image. But this is still not our entire, this is still not what we want. We need to, build this code and then and then run that binary. So our final goal would be to have something like this. So just like we have Docker run, just like Shantanu showed, Docker run Ubuntu, and then it starts a shell, right? So we want something like that. So we need to build our code first. So let's do that. Just before we do that, I usually like to, have all our code in a specific directory. So I'll just do that. So this is another command, which is run. Run basically runs any command you mention after it in the context of the container. So this is run inside the container. So if I enter an invalid command here, it will return an error if the underlying image does not recognize it as a command. So if make the dir, say Windows doesn't, or says if I was using something else here which did not have make dir as a command, so this would fail. So now I'm creating a /app directory, and then I'm setting my work directory to that path. That basically means everything that I run after this work directory command, it will be relative to this path. Okay, it's just like doing cd to some directory that becomes my current working directory. So now the dot here would mean that the destination dot here would mean it's inside /app. Okay, let me know if this is getting too confusing. I think I've spoken for quite a while now. So yeah, if you guys have any doubts, I haven't seen the question tab also.
Yeah, just one thing. I guess folks using the lab will not be able to type this, so make sure to maybe push it so they can pull it and do it maybe. After the entire thing is done.
Oh yeah. Sorry. Yeah. I shouldn't have used the code editor. My bad. If you are using lab, you should.
Lab only has V, so it's
yeah,
it's fine. I think code editor is fine.
Fine. Nice. Yeah, let's just do it. Yeah. So yeah, we have copy here, right? And yeah, let me just check the question tab.
There is one question, by the way. You can just.
Yeah, I'm trying to open that itself. I stopped the presentation. My bad.
Okay, I can tell the question.
Yeah.
Should we always use Alpine images, or what are the trade-offs of using Alpine images over other distributions like Ubuntu or CentOS?
Yeah, we'll come to that. Actually, that is once we finish building this image, I'll share why you would prefer an Alpine image. Uh, but usually the thing is that when you are pushing, just to give you a hint. So the image that you pack will have some size, right? So as you saw, Ubuntu was around 100 MB, or there are images which go up to 5-6 GBs. You would usually want your image to be as small as possible while performing right, like while performing correctly. So that is when these optimizations come in. Alpine is a very tiny distribution, so people try to use that. But there are some trade-offs of using Alpine also, and I'll mention it in the end. Yeah. Okay. So if we go back to the terminal, yeah. So now we have we have created our work directory, copied our code there. The next thing, anybody should be able to guess it, would be to build our code, right? And how did we build that there? Yeah. So how did we build it here? We use Docker build. Docker build. Sorry, why? Oh yeah, we use go build, right? We use this command. Correct. So we need to do this again. But before this, there's one more thing we need to do. Okay, and that is, so usually when you have your apps, you'll have some external dependencies also. Correct. A very simple example is when you are writing a simple web app in Node.js, you will have all those Node modules that you need to have in your, you need to install with npm install before you can run your Node app. A similar thing in Java would be you use your Gradle thing to download Java packages and then run. Same thing in Ruby is bundle and your Ruby gems. Correct. A similar thing in Go is Go modules. So I can list you all the dependencies that I can list out the dependencies that this app is using with this. So yeah, this is my module name, and it requires this dependency GoGin. This is the framework, the web dev framework that I'm using for this writing the server. So yeah, these are the dependencies. So I need to make sure that those dependencies are available in the image also during building, right? In the which so for that I need to add one more command, which is So I do run go mod render, and what this does is it installs all the required dependencies into the folder which will be used while building your app, right? And then I do run go build the right. So yeah, this will build our app. I could also do this. Remember, because everything after the run command is just something that will be passed on to the image shell and run there, right? So I could do this also. This is basically running two commands together. You can do this in your normal shell also, but there's a reason why you would do this. At least in this case, there's a reason why you would want to separate downloading dependencies from building your code, and I'll let you know why that is a bit later. But okay, so this should build our code, and yeah, we should have the binary available, right? So if I just see this, oh, why did I exit? And I do Docker build again. It shouldn't have been. So now it's download. You can see the output of the command. It's downloading the dependencies, and then it's running go build. And you'll see that a lot of layers are formed here. And as I mentioned earlier, there is a layer formed after every instruction. So the first instruction, a layer is formed. And you notice this is exactly the same hash which was there in the first version also when we only had this instruction, and that is because the result is exactly the same. Then we run this instruction, which it spawns a new container in which it uses this image and adds this instruction to it, right? So it runs this command in the container, and whatever the result of that container is, whatever the file system and all those data is stored, and a new image is created. Again, that is used, and all these steps are added incrementally till we have the final image here. Yeah. So yeah, see, you can read the output also. It says removing intermediate container. So this is something that I wanted to focus on, that when you're building an image, it creates a container, it executes the instruction, and then removes that container, and whatever the new image was, whatever the new data was from, it creates a new container out of it and adds the next instruction incrementally, right? So yeah, we have a final image. Who the hash is this, and the tag is again this. So we can see the image here. Yeah, so Pongo, and the size is 396 MBs, right? So yeah, 396 MBs is decent. It's not very large. Yeah, so and now we can run this too. Docker run Pongo v1 ls, and remember that we moved all our code to /app, so we'll ls/app here this time. Right. So you can see all this is from our code. This is the binary that was built. And this vendor directory contains all the downloaded, dependencies. It's like your node modules folder in your, in a project, in a node project. Now, if we try to just do this, nothing really will happen. So if we say what it executed /bin/sh, right? But we don't want this. We don't want it to run shell. We want it to directly start this binary when we give this command. So this is when another command in the Dockerfile comes in, which is the entry point. So entry point lets the when you're creating the container, entry point in the image tells the container that once you have finished setting up the file system and everything for the container, this is the first thing that you need to do. This is the first process that you need to start. So I can write entry point, and this is just the syntax. So you need to pass it an array of strings. So those are basically your different arguments. So here is just session 1, right? Yeah. Before doing that, I'll just change this command a bit. /bin/Pongo. Yeah. So this is just a slight modification. What it's doing is it's telling that after you build, instead of naming it as session 1 and storing it there itself, share it in the /bin folder, which is there in the path by default, right? So I don't need to do all this. I can just do Pongo, right? And this should work. We should have our image now. So let's build this. Okay. Okay. So yeah, we have added the entry point command, and we have our final image Pongo v2, and this has the hash 7f9 whatever, and yeah. Okay. So once we have done this, all we gotta do is run the. Yeah, let's try running it now. I hope so. Yeah. So now, and now we have successfully packaged our app into a container. right? Now this is where the things get a bit complicated. Right? Now we have successfully packaged it, but mind you that this process is running inside the container. So if I do Docker PS, yeah, you should be able to see that it's running, and the command is running is Pongo, and yeah. And now, if you're using Docker the first time, you would expect that you should be able to ping this and get the thing right, like we did earlier. So localhost, yeah. So you would expect to get a pong here as a reply, but you don't. The thing is that the port that it is using, the where it is running, it's the container port, not your host port. So when you tell curl localhost 8080, or in fact, not only curl, anything that you run on your host, it's in the context of the host, right? So the port here is the host 8080 port, correct? But the process actually running in the container and on the containers port, which is containers port 8080. And these two are very different, right? These two are totally different. So that's why you can't really, curl it right now. And this is when there's something called port mapping comes in. So port mapping is basically, as the name suggests, what it does is it maps the port, a given port of the container to another port, to a port of the machine, right, of the host. So, and to do that, what you do is Docker run this same thing, and you pass a flag P, which stands for port mapping, right? And you tell it the port of the host that you want to be mapped, and the host of the port of the container that you want to map, right? So this is the destination, and the second one is the source. And I can do Pongo V2 again. Yeah. So now again it's running on port 8080. And now if I do Docker PS, yeah, you'll see that there's one more thing that is added. So earlier only this data was present, but now in the output there's one more thing is added, which says 0. This to 8080 TCP. This basically tells that the port 8080 of host is mapped to the port 8080 of the container, right? And now if I do curl, I should be able to get the answer. So this is another kind of isolation that Docker provides, that by default your ports and all are totally separate. So a port on the container is not the same as a port on your host. So this might be a bit confusing for you right now because I use the same port. Let me try a different port. I didn't, because even I don't remember what's the order of source and destination. So just use the same port and no one will know. Let's just try again. Yeah. So yeah, again, the server inside the container is still running at port 8080. If I do Docker PS, yeah, now it says that port 9090 of our host is mapped to port 8080. At least that is what I believe. So if I do curl 8080, it should work. And if I do curl 9090, it will. Oh, sorry, my bad. Yeah, it works. So so this is how you can map given ports of the host to given ports of the container, and you can pass this flag multiple times. So if I want to port another port, map another port, say port 8000 of the host with port 80, which is the standard HTTP port of the container. This is what I would do, right? So yeah, I hope this part was clear. This people who, yeah, you can raise your hand, and if you were able to follow this up and try it on your own, well and good. If not, it's totally understandable. It's the first time. But if you have any questions, do let us know. Do let me know. And if you understood this, just raise your hand.
Yeah, there's a question in the chat, in the slides. Should I tell it?
Can we run multiple Go applications in the same container? That one, right?
Yeah.
Yeah. Huh. Yeah, you can start multiple process in your container. It's not an issue. So as I said, one way to do that would be, start my container and then do Docker exec side by side. So actually, let me show you. So yeah, the same thing. Now I'm running this process. This process is running in the container and listening on the containers 8084. I can do again exec. What's my container name actually? Yeah, and again try to run Pongo. Okay, and it should give me an error. Why? Do you know why? Like, can you guess why? Can anyone guess why? Okay. So why it should give me an error is because I'm trying to start
Someone
another.
raised a hand. Naman Trivedi raised hand.
Naman, do you want to answer, or is it
Yeah,
that you understood?
there is a server running on the same port inside the container, so you cannot run two servers.
Exactly. So you can't have two processes just like that bound to the same port, right? So this should give an error. Yeah. So I got an error from the server that it's already in use. Thankfully, like I gave. I hope this works. Yeah. So I actually gave an option to, you know, uh, I'm not sure how I do that. Run it on different port by passing an environment variable, but for that I'll have to modify this a lot. So I would have to do sh. Yeah, this should do. I think. No. Yeah. So yeah, this is just some shell complications that happen. So I had to do it like this. But if I pass it, if I set the environment variable to 9,000, the server listens at 9,000. And now I have two processes running inside the container. And yeah, so it's at 8080 and one is at 9,000. And if I had mapped this also during container creation, I would actually be talking to two containers, one with this and the other with this. Yeah. Okay. So does this clear your doubt? Again, there's no real way to know it, but okay. Yeah, so this finishes our image building part. Yeah, so I didn't see a lot of hands raised, but okay, I think it was a bit complicated, but yeah, I hope most of you understood at least bits of it. Yeah, did someone
Yeah,
want to say
maybe
anything?
after the session we can push the Docker file to the GitHub.
Yeah, definitely. We'll push the final Docker file. There are a few changes that we need to make still. So coming to image optimization. This is the final topic. Yeah, this session has already gone for too long, but okay. Yeah. So if we see, if we list out our images, yeah. So we have two versions, V1 and V2, and both are 396 MBs. Okay. Now this is a decent size, and in a lot of cases, when you have large code, large binaries and stuff, this is acceptable. But because I know that my code is very small and my binary is not really large and stuff, even the dependencies are not. I know that it shouldn't take this much space, right? So also I'm using the Alpine distribution. So if I just look at the base Alpine image, Docker image, full Alpine, see if I don't- Yeah, and if I see the size of my Alpine image, damn, where is it? It's just 5.61 MBs, right? And the Golang image, the one which we are using as a base image, is 301 MB. So that means that on top of Alpine, the creators of Golang have actually added a lot of stuff to make sure that Go runtime is available there. And it's the Go runtime that is taking so much space, right? But the thing is that once I have built everything, once I have the binary, I don't really need all those tools for running, for compiling Go and all those stuff. I just need the runtime, which is definitely going to be there in Alpine, and just need the binary. So what can I do for this, right? So if I go back to my Dockerfile, so this is where optimizations come in. Okay, once you have an image, you want to optimize it and reduce its size and pack it into the smallest, make it the smallest image you can. Okay, so let's go back to Dockerfile. Okay, so things that I don't need in this is once I have the binary and I put it in /bin, I don't really need the code, right? Does anyone think that we need the code after we have the binary? Yeah, I hope don't. Yeah, I hope not. So so we don't need the code. So what we can do is remove the code. rm rf /app. Don't forget the app here. So this should remove all our vendor directory, which had all the dependencies, and the code too. Though the size of the code wasn't much, it was just in KBs. So we won't probably see a lot of difference. But by doing this, I just wanted to demonstrate one small thing. Okay, actually, let me just make the code a bit larger. Right? So /dev large. Yeah. So now we have a very large file in our code, which is 347 MB. Oh damn, I made it too large. Okay, small. Yeah, so we have 167 MBs of some file in our code. Now, if I do docker build pongo p3 and let it run, first it sends the context, which itself is quite large, and then I just wait. Notice how the copy step took very long here this time because it was a huge file. Yeah. Yeah. So we have built version v3, which contains a large blob. And if we just, I did RMRF also, my bad. So this is v3 without the code. Okay, so let's just see how v3 looks when we have deleted the code. So if you notice here, this is the mistake. I shouldn't have run this. I would need a base first to compare against. So anyways, we have this in which we remove the code after we built the binary. And let's see what the size is. So Pongo v3 is 571 MB, right? And now we would expect this size to be smaller than what it would be if the code was there. So let's not remove the code and try then. So where is my? I'll close it again. Yeah. So if we just do this and build it again, so this is our Dockerfile now. The RM is not there, and do Docker build Pongo with code. Yeah, so this is Pongo v3 with code. And if we see the size of this, it's the same. And why do you think this is? We would expect it to be more because it has the code, right? Or at least, or forget this. We would at least expect the one in which we remove the code to be lower than the size of this, right? But that didn't happen. And the reason for that is because, again, in how Docker works, right? So there is something called image caching. So this is, yeah, so, okay, let's move point one. So first thing is choosing the right base image. This is, we discussed earlier also that I could use Ubuntu, but I went with Alpine because it's lightweight. So yeah, same thing. Alpine images are lightweight, but you can sometimes have, dependency issues because the the libc the libraries which are packaged into Alpine are actually Muzzle libc libraries, not glibc. glibc is like the standard C library which is used everywhere. Most of your applications are compiled using that. Even in your Linux distro, it is the glibc that's being used. So if you try to run an application which needs glibc in Alpine, it won't work, right? So that is when you can have some issues. I guess someone had asked what are the disadvantages. So this is the only disadvantage that I could figure out. Like, so this is something that I faced when I was building a, a Ruby project, and that is when I faced issues with Alpine. Other than that, you don't really have any issues. You should, if you can, always go with Alpine unless you don't have all the, you can't run your dependencies there, because of these issues. The other thing is to know about how image caching works, right? So what we saw here, so what happened was that, uh, why didn't the image size reduce? It's because even though we have removed our code and that large blob, which was quite huge, it's still stored with the image. That's because the different layers of the image are cached and stored in the image itself, right? With the image. So, all these layers you see, these are actually cached. So you can see the output here. So if when I run this command, it says using cache, right? When I run this command, it says using cache. When I run this command, it does not say it's using cache because some of the files in the context changed. So now it's not using cache. So, but the thing is that it always keeps a cache with it, and all these layers are actually part of the image. Okay, that's why when you pull an image, you see that it's downloading different layers. So even the layer which contain the code is part of this image, correct? So because that layer is also part of the image, you can't really reduce the size of the image by just deleting your, by just deleting your code, because that code is somehow still there. It might not be there in the final file system, but it's still part of the image. So what you actually need to do is, now you might think, then why do we have all this layering and caching? It's just useless. But this is actually very useful, okay? And I can show you why. So now if you see, once I copy and I run go mod vendor, it downloads all the dependencies, right? But how many times do you think your dependencies actually change when you're working on a real life project, right? Right now, I changed the code several times, at least the Dockerfile and stuff. Even if I was changing this, maybe adding some new path here, say, yeah, something. I can just change this to, this. Say I change the code, right? My dependencies here, the Go mod file won't really change, right? So I don't really need to download these dependencies again and again. So it would be really good if I could just cache this somehow. And the next time I'm building the image with the updated code, I won't really have to download this again. I just want an output, something like this, using cache again. And that is actually possible. So what I would do is edit my Dockerfile and just follow. Just try to understand what I'm doing. Okay, I'll just make a few edits. Yeah, what I would do is I would copy go dot mod here. I'll copy go dot sum here and do run go mod vendor. So what I'm doing is that for downloading the dependencies, I just need these two files, right? The go the Go tools only need to know what packages are there. So I just need these two files, and these two files are not going to change, correct? So because these two are not going to change, these two files, the output of these commands is not going to change, and hence it'll still use the cache will still remain valid, and Docker will use the cache. So this is like a simple, very simple cache of how you think it works. So if the new output, if you know that it's going to be the same as the old output, you just use the old output. If you know that it's not going to be the same, then you have to do everything again. It's a very simple cache, right? Now when I've created this, right now when I've downloaded the files, the dependencies, I can just copy the remaining code like this, right? And then continue whatever I was doing. And what will happen now is that all your steps till here will be cached in your subsequent builds, and only this part will run again. And this is something that when you are writing your Dockerfile, you need to take care of, that you want. So one thing is you need to make a Dockerfile, the Docker image, try to make it as small as possible. And the other thing is that you need to make sure that it's, the build process is as fast as possible. Like wherever you can use caching, try using the cache, right? Yeah. So if I just run, if I just save this and try building now, Docker build Pongo v4. So the first time it is still going to download again. So yeah, all match no packages is interesting. Did I not copy it right? Yeah, I think I didn't copy it right. Interesting. I think I need to change something. Let me just remove this block. Actually, even I'm doing this the first time, so let's see if that actually works. DB. Interesting. Why? Okay, one last try. If it does not work, we'll just skip this and just pretend nothing happened. Cat mod. Warning, all match no packages. I have no clue why this is happening. Acha, so there's no package that is being used. Okay. Yeah, so this is something that board is, I'll have to copy, may not go there. So yeah, I'm not sure how I can solve this right now, but there should be a way to catch this. Anyways, yeah, let's just pretend nothing happened. So we'll go back to our original file. Oh, I need to go one back. Yeah. So yeah, we vendor it and build it. But again, as I said, coming to just take the caching thing. Just it didn't work here, but that is how you would usually do it. Okay. I don't know why I've never tried it before, but it always works with node modules and your Ruby packages and stuff when you're using Butler. So you always download the when you're running when you're building a Docker your node image, you always keep download the npm install part separate. So the next time when you change the code and run your Docker build, the dependencies are already cached in the image, right? Okay. The other thing that I want to mention is multi-stage builds. Okay. Yeah. So what multi-stage builds are, that you create one image, then you use some parts from that image into a new, in a totally different image. So how can that help? So when you're creating an image like this, just one build, what you're doing is that all the results are stored with this image, the final image, right? And that increases the image size. But I don't need the entire thing in this image. I just need the built binary, right? So what I can do is I can start a multi-stage build. So I am creating another image which will use the result of the previous image build. And here I'll just use Alpine. So as we noticed, Alpine was quite light, but the Golang Alpine version had a lot of things installed which made it around 300 MBs, while just Alpine is 15 MBs or something. So I'll just use that. And I need to name the previous image so that I can reference it in the next image. So I'll just name it as builder because I'm building it here. And I don't need this entry point here. I'll need it later. Okay. So yeah. So from Alpine. And now I just need the binary, right? Which is Pongo available at /bin/Pongo. So what I'll do is copy from, this is this syntax that you need to mention, and the previous image name, which is builder, and the path, the source path, which is /bin/Pongo, and my destination, which is again /bin/Pongo, right? And then I can just do entry point. Yeah, that same thing there. So yeah, I can just do this, and I'll have my, so the final image, the actual image that will be built is this one, and this is just an intermediate separate image, not not a layer, but a totally different image that will be there, and this image size will be large, okay, but this new image that we built will be quite small. So let's just, I hope this works. Yeah, so let's name it V5 multi-stage. So first, it's building the first image as builder. Just notice the output again. Yeah, and now once it has built that, it is starting another image on the side and tagging that only as this is a result, right? So now if I just try remembering this hash, where is this? Yeah, 629. Yeah. So if I just do Docker images now, Yeah. So we have our final Pongo with V5 multi-stage, which is just 15 MBs. Okay. And we have another image with the tag with the ID 629AF, which is exactly the same as this one. Where did it go? Yeah, here. So it's this, and whose size is 396? Its size is 396 MB, which was, remember, the actual size of our previous images that we were building without multi-stage build. Yeah, here we do. So what happened here? As I said earlier, it created an image, tagged it this, gave it this ID, and from that image, it just copied some of its parts, and we specified what to copy, just the binary, and put it in a new image. And this new image does not come with the baggage, of all these layers, right? It just, how many layers do we have here? So 1, 2, and 3 layers, and all these layers are quite small because the binary is quite small, and the Alpine image is also very small, right? And this does not technically does not add much to the file system, so it does not really increase the size. And it's just 15 MB. Now 396 MBs to 15 MB is quite a huge difference. Like it's a huge compression. So this is something that you should be always trying when you're building your Docker image, that try to reduce the size. And yeah, so this is when multi-stage buildings can be really useful. Yeah. So okay, so this is it for the session. If you guys have any doubts, you can ask them. Were there any questions later? Okay, there were no questions. So yeah. So this is what I was mentioning. Yeah. So yeah, one last thing is propagating live changes to code. This is something that I'm not going to show here. I would leave this as a homework. One clue for this would be using Docker volumes, that to bind mounts in particular. And yeah, so this is it. That's it for this session. If you still have any questions, you can ask them directly, put them on chat, or put it on this link. This PPT, this slide deck is available on this link. You can scan it. And the repository is, again, you already have the link, weblab and itk/container. So yeah, thank you. Any questions? We'll wait for like 2-3 minutes.
Yeah. So in the Dockerfile, you did not use any expose command. So
Yeah.
is it optional, or you always need to specify the ports which container might open?
Okay, that's a good question. So right now, I didn't need the expose command. So what he's talking about is this. Where is my tablet? Yeah. So what you can do when you are building, so normally what practice is followed is that, say my server is Pongo, right, and it listens at port 8080. So you would write expose 8080/TCP. I think, I'm not sure. I've not used it a lot, but yeah, this is something that you put in. Yeah, let's just try to do this. Yeah, so while it builds, so this is something that you put in the command to tell Docker that these are the containers that the container will be using to at which some service will be listening on the container. So now when I do Docker run, and just don't even do port mapping, give port map, and just do E5 multi-stage, and if I do control shift, you'll see that the port is still listed here, though it's not mapped, it's listed. When is this useful? So this is useful when you want to, create a network of containers, okay, which talk to each other. So right now we're just running a single container, but in Usually, and actually most of the times, what happens is you are running a network of containers. Okay, so you can also create a virtual network using Docker and add containers to that. So remember when Shantanu said that you can totally isolate the containers? That's not really true. Exactly true. Like you can still make them communicate through your normal networking, right? Just like even VMs, two different VMs can communicate through a network. You can do that here also. So again, and then that is when expose is necessary. Okay, so when you put expose 8080, it lets other containers talk to this current container at the port 8080. Okay, otherwise Docker wouldn't allow you to contact the port 8080 directly. So that is when it's useful. Does that answer your question?
Yes, it does. So
Yeah.
by meaning of talking between two containers, you mean the Docker network namespace, right? The separate namespace of Docker to containers are talking, not in the host namespace. Like
Yeah. So when you're running container, it runs in a separate Docker network, right? So,
yeah,
so if I just list the current networks, so the first one, I'm not sure which one, but one of these is the default network, which the containers use if you don't specify a network. Okay. So I can just see with this what network this container is using. Yeah, so it's using C98, which is the first container here. Yeah, this is the container. This is the network it's using. So by default, all the containers are added to this network. Okay. This is a virtual network created inside by Docker inside the OS. Again, as Shantanu said, we are virtualizing OS resources. So we are creating a virtual network. And now to allow another container to actually be able to, talk to port 8080 of my current container, I would have to give expose port in the image. Okay. Yeah. Any other doubts? Yeah. Again, you can access the slide deck from this link, and yeah, the repository is available. We'll push today's Dockerfile here, and also all the following sessions. Any code that they use will be pushed to this repository.
Yeah, and this recording will be available on YouTube, right?
Yeah, we'll upload it on YouTube.
So, we can probably put the link of YouTube in repo only, or how do we?
Yeah, we'll share it. We'll share it once we have the YouTube link. We'll share it.
Okay, cool.
On the repository, and we'll share spam also.
Yeah.
All right, we'll wait for another minute, I guess, and then if there are any questions, you can just put them up till then. By then. Also, I hope this session was useful and was not just these things going into your brain and not really making any sense. Yeah, I see a lot of people have left, so I guess that's it.